Okay guys, here we are back again in the second part of this tutorial, and right now we're going to type the algorithm, or maybe let's say the script of what we what we talked about in the previous video, in the part 1 of this tutorial. So let's jump right into it with this. The first thing we need to type is clear, because we want to maybe reset the workspace of our environment. So let's say clear and CLC to clear the command windows. So now I need first, because I'm not alone, I'm with you right now and we're working together. So we need as input the value of D. So let's say enter the value of D. You see D like the constant of our equation. This one, let's see, this one, we want this one, the value of T at 0, the value of T at n plus 1. So we want this one and these ones, and we also want the value of delta x to the power 2, and also no, that's all. Okay, so we're here. So then we need the value of k. So let's say input, enter the value of k, double quote, not double dot quote. It's like the lyric of a song, double quotes. double dot and quote, double dot and quotes. So I'm up here, back again. So we need t at 0. So let's say t o. Okay, it's equal to input in, not in, input. So let's ask the value, enter the value of t at 0. Okay, that's it. Now we want the value of t at n plus 1 node, but let's call it t at n, and let's say input, give the value give the value of t at n plus 1. Okay, so now we want the value of delta x. So delta x is let's call it dx, and say input we can call this one the, let's say the lag step, maybe. Yes, into the space dimension. Okay, say let's call this one name FNC FWD. Now after that we need to let's run back here. We are going to create a vector, something like a table with just one column. So in that variable we're going to store the value of this one or maybe a factor of this one, and all the values say 1 1 1 1 1, and on the last line, so on the last entry of that vector, we're going to have a factor of this one. So it's simple to understand. You just see how to let's say how to fill the value we need for this purpose. So we first need something with two dimensions, so row and column, and in the first position of that one, sorry, we're gonna have, oh, give me a little moment. All right, we need to fill this matrix with the value of, in fact, developing the equations we got in the first part of this tutorial. We are supposed to reach to this point. So I have this matrix with a value like this, minus -2 here, 1 0 0 0 to the end, and 1 -2 1 0 0 to the end. This is regarding to the equations we have in the first part of this tutorial. So this is why here you have this variable we're gonna fill with this value. So at the first position we're gonna add -2 -2 times this value, and I'm gonna make this for the first line, second line, and the line number 10. Okay, so let's make this. We need here -2 time, let's say for example it's d over the value of k, and the value of dx to the square, to the power 2, or to the square. It's the same. So yes, I guess this is what we need at this. So the second one we need to fill before we run the loop is this value, only this one, because it's one time this, so we will have this just like that, and that's it. Okay, and the next step is to put this value inside it's like the initial value of this vector. So let's say let's call that one f at the position 1. So I want to set the first value of sorry, this is not corona. 1 negative, no, 1 minus 1 minus d, oh sorry, d, and t is o, and the o, this one slash the k value of what? K value of dx. Yep. Okay. Now, oh, sorry, a second. So now we start the loop with this k equals to 1, going from 1 to no, we want this to go from 2 to 9. You'll see why. So inside this I need m position k. K k minus 1 equals to let's say 1 d. This is this value. Copy paste right here. Okay, and I'm at the position. We want this position to be now 1. So kk. Okay, at kk it's negative 2 times value, and at the position sorry kk 1 we want it to be this one. So we save. Before we close the loop, we also need to put some values inside the other one. So if 0 at the position k, it's 1 only. So look at this. Yes, it's supposed to be 1 because for each other line or equation, we're gonna have t plus t at the position e plus 1, t at the position e, and t at the position e minus 1. So there won't be this quantity right here. So this one will be 0. So the only value on this side will be 1. So this is why we have 1 1 1 1 1 for the rest of the equations. But for these two particular state of the first equation, we have this quantity for the first line and this one for the last line. So this is why for the other value of the vector we're gonna add only 1. So now at the end, after we're done with the loop, we say if at the position 10 its value is 1 minus the quantity, but right here we need to add something here. So it's t at the position n, so it's this one. And we also want to fill some of the values. Yeah, this is yeah, this one. So line 10 and column 9, the value is this one only, because it's 1. It is 1. But at the position 10 it's negative 2 times that value, so that quantity. So at this step we're done with we already have this and this. So now we just have to say the value inside this one is equal to this over this. Simple. On Scilab and MATLAB it's simple, real simple to achieve. So let's say now the value we're looking for, it's called t-var, and it's equal to over n. Yep. Say now we can just plot something like this. Let's say we want a line but with some stars on it, and we want it to be red, and put this in and say now we run it. So let's say d is equal to 1.5, so k is equal to 2. Now the value at 0, let's say 25, and we so this one 0.5, and this is the output. So you see, if you're familiar with this type of equation, you will notice that the solutions most of the time look like this. So that's it. That's the first step of our hybrid process. So now, what is the meaning of this? The meaning is, after, let's take this one close to this, and let's say we want to show this on this side, and let's close this. So the meaning of this is simple. On this position the temperature is 21, and on this it is 17 point, this one, and on this point that's the temperature, and on the last, this one, the temperature is 0 point something, these values. Okay, so now that we have the value of the temperature on all these points, we're going to use them as input. We're going to use this value as input value to compute or maybe calculate the value of the temperature on each other point of this line, and use the Wayne level process, and it's stochastic. So yeah, definitely. Let's see you guys on the second step of this workshop, and we're going to talk about the Wayne level process. See you guys. Signing out.